Good morning everyone. Today we are presenting our project title Double Stage DC to DC Boost Converter with ISO MPPT for Solar PV System. This work is guided by Dr. S. Alhamal Ma'am, Associate Professor of Triple Department. Our team includes 3 members. They introduce themselves. Hi everyone, I am Samavati.
Hello everyone, I am Naveen Kumar.
Hello everyone, myself Navneet Krishnan.
Introduction. As the demand for renewable energy grows, solar PV systems are becoming more common. However, the system generate low voltage output. Traditional boost converter can't efficiently raise the voltage and often suffers from high switch stress. To address this, we proposed a novel SSIN based converter. It's simple, use a single switch and achieves high voltage gain. Additionally, to extract maximum power under varying condition, we use an improved snake optimization algorithm with better initialization and faster convergence. Motivation. The motivation for this project comes from the limitation in the traditional MPPT methods, which struggles to convert minimal solar energy efficiently. Especially in mobile or load varying systems like solar powered motors, energy output is inconsistent. Our goal is to maximize efficient and test the performance of the ISO algorithm in real-time scenarios.
Energy to electric potential. We know that output from solar panel is not constant. Hence, a controller should be used to track the maximum power and a buck or boost converter as well to meet the requirements of the load. Here, let's discuss about the modes of operation of the proposed converter. In mode 1, as the switch is on, inductors L1, L2 and L3 starts charging. As they are charging, negative potential is developed across the anodes of the diodes D2, D5 and D7. Hence, they are reverse biased. Due to this, the terminals of the capacitors are such that they will be discharging to the output capacitor on the load. Applying KCL to this network, we can obtain an equation on. Previously, the inductors are charged. Moving to mode 2, in this mode, inductors will be discharging. Hence, the inductor terminals changes, D2, D5 and D7 will be forward biased. The inductor discharges to C1 and C2, means C1 and C2 are charging. Applying KCL to this loop, we can get equation 2. Moving to mode 3, mode 3 occurs simultaneously with mode 2. The charged output capacitor in mode 1 will be discharging to the load.
This is a flowchart of improved string optimizer MPPT algorithm, which is derived from the traditional MPPT algorithm. Unlike slow convergence and post-search stability, is overcome by using Levy-Flight strategy and dynamic exploitation probability. By assigning the duty cycle randomly within the number of iterations, we can improve the output of the solar panel, which is iterated again and again to find the best duty cycle and provided for the switches input, by which the output of the converter can be improved. These are the readings taken from the simulation. For change in the radiation input, the output power can be improved. The converter output for change in different voltages input with the constant duty ratio is seen here. For change in load, the gain is always constant. For change in duty cycle, the output of the converter is changing. This is the experimental setup of our project. This is the solar panel from which the voltage and current readings is sensed by this voltage sensor and current sensor, fed it to the Arduino. By Arduino contains the ISO MPPT algorithm, which runs the algorithm and produces the duty cycle, which is fed to the MOSFET switch to control the entire boost converter circuit from which the output is derived. Graph represents the diode voltage waveform with respect to time taken from the simulation. Graph we can see the 3 inductor voltages with respect to time and 2 capacitor C1 C2 output voltage waveforms. Output of the converter circuit, from which we can see that without using any controller, the output is very fluctuating. By using the ISO MPPT controller, the output of 350 volt is almost constant. Solar energy is a free and renewable form of energy which promotes clean energy adaptation, improved energy access, enhance system affordability. By this project, the people could sell the excess power to the grid and earn money also. Thank you.